Hi, this is Francis Sideco with TIRIAS Research. I'm here with the newly rebranded QNX guys at CES 2025. I'm here with Christ Habib, who is a senior technical product marketing.
Product manager.
Product manager, sorry.
It's all good.
I used to be a product manager too. There's a big difference, and definitely want to get that right. So, Chris, why don't you tell us what you guys are talking about, especially on QNX Cabin?
For sure. So this is our latest and greatest digital cockpit development platform that we just released. And it's a software stack that runs on top of the QNX hypervisor. And it's a hardware agnostic solution for OEMs to quickly accelerate their development of digital cockpits. Right. So what you see here at this booth is actually QNX Cabin running on top of the QNX hypervisor on top of the ARM hardware boards in AWS. Right. And what we're showing here is actually that you could use simulated data, in this case from our partner DSpace. You could pump that data up to the cloud, right? Do your development and test, right? So it could be recorded data, it could be live data, for example. So let's turn on the hazard lights, for example. You can see the hazard lights are flicking on, turned on also in the guests. Or you could do hardware in the loop, right? So it doesn't have to be simulated data. You could even do, for example, hardware direct data from your connected devices. So in this case, I just jumped to another instance that's connected to my hardware devices. If I just zoom in on, say, the Android, for example, I could do something like take in my voice, testing, 1, 2, 3, right? And the beautiful thing is you could do all your work in the cloud, develop, test, and then take it just so seamlessly from the cloud down to your actual hardware boards, right? This solution, this software stack, QNX Cabin, is running unmodified in the car that we have here in the booth, and the two different SoCs in the back there, and a different SoC over on the other side. And that's the power of QNX Cabin.
So I know we're going to go look at those specific QNX cabins for specific SoCs.
Yep.
And this particular bit here is hardware agnostic. So I assume, is there a level of customization as you go to a particular chipset
Yep.
once you're done developing at this stage?
For sure. So the way we've done this hardware agnostic solution is we've created an abstraction layer within our hypervisor that allows all the apps, and including the guests, right, that you see here, to actually have a common interface down to this abstraction layer, such that when you move it from the cloud to one SoC or to a different SoC, everything above that layer remains consistent, right?
Perfect.
What you have to change is that BSP that's specific to the hardware.
Yeah.
Now, we, of course, optimize the QNX Cabin software stack for those hardwares to make sure that you get near native speeds, right, and performance. But yes, there will be some customization that you will have to do for those particular boards, right? But with QNX Cabin, what we've done is we've shrunk the amount of churn that you have to do in your software code. So let's take, for example, the guests, right? This Android and Linux. These are straight from open source, from the web, right? You don't have to customize it for your specific hardware. So what that lets you do is basically whatever you do in the cloud, you do it once, right? And then you take it from this platform to this platform to this other platform without having to redo your work, right? That's the power of QNX Cabin. Now, the other advantage, of course, because it's cloud-first development, you could do your work before the hardware arrives, before you even pick your hardware, or you could even integrate it into CI/CD pipelines and automate your entire workflow.
What happens with hardware-specific capabilities that you might be trying to tap into? Is that just a matter of having a close partnership with those SoC people and understanding what's coming down the pipe, and then are you able to start developing on that before you even get that capability?
Yeah. So, for example, let's take graphics. So you could do your HMI right here. So we provide a software-based GPU, right, that lets you do your graphics development in the cloud. The graphics actually goes through our framework called Screen, right, which abstracts away that hardware. And then Screen is the one that connects to that specific driver, right? So when I said earlier that all you have to do is swap out that BSP, right, really what you're doing is you're taking all that on the top, putting it back onto the new BSP, and Screen, that framework piece, just talks to that new driver that's particular to that board. And we, of course, work with all our partners to make sure that everything works just seamlessly.
And just because it's 2025, I got to ask you about AI. How does AI roll into this as you work with some of I know, obviously, like people like Qualcomm have AI Hub that they're bringing in when you're trying to do, AI-based apps into their systems.
Yeah.
Is QNX Cabin kind of ready for that as well?
So funny that you mentioned that. In one of the demos that we'll see later on when we go to the other stations that are running QNX Cabin, you'll see one of our partners are actually using AI to do DMS, driver monitor assist, right?
Perfect.
Great. Thank you. Okay, so we moved over from QNX Cabin running in the cloud over to QNX Cabin for SoCs. So what you're seeing here is actually what was running in the cloud, now running on physical boards unmodified. Now, I'm going to pass it over to Luis so he could give you a more in-depth explanation as to what's happening here.
Thank you, Chris. So what we have here is what Chris already introduced. It's QNX Cabin, which is our reference digital cockpit framework, already pre-integrated. So what we have here is we have QNX, we have an Android guest and a Linux guest as well, and they all share the hardware. Okay, so you have here the camera view from QNX. If I go reverse, this is Android rendering the camera video stream, and same with audios, GPU, and all the most important components that have to be shared. We use open interfaces for that, so we are not bound to any silicon-specific technology. That's what makes it fully portable and hardware agnostic. So you can run exactly the same binaries on MediaTek, Samsung, in the cloud, Qualcomm, or anything else.
Perfect.
Hey there. So we've taken you from QNX Cabin running in the cloud over to QNX Cabin running on real target hardware with unmodified code. Now we're at this station showing you what the QNX Cabin might look like when you've taken it and actually customized it for your own needs and ready to go to production, right? So here we have QNX Cabin, again, running on an automotive SoC with some enhanced GUIs and features to kind of demonstrate the power of QNX Cabin for you.
And just for context, we saw MediaTek and Samsung over there.
Yep.
This one is based on Qualcomm's Snapdragon chipsets. Obviously not the Elite, right? This is their previous generation.
Yes.
Okay, perfect.
Okay, so I'm going to hand it over to Mike now, who can speak more to it.
So thank you very much. So what we have here, as was mentioned, this is the QNX Cabin on SoC. So we're going to showcase this is a 5K display, so it's a lot of graphics, very very intense. We have a single interface to the screen. Just one SoC is driving this. That's a Qualcomm 8295 SoC. Just going to close this up. So we have 13 different virtual displays as part of this demonstration. Some of them are running different types of graphics environments. Okay, so you've got so anything that's blue, that's QNX. So that could be based on let's see, your Qt or OpenGL, WebGL, whatever you'd like. Anything that's in green, that's Android, but that's running on top of a hypervisor. So it's isolated. So it's mixed criticality between the two different operating systems. So what I'm going to showcase is a few of the graphics demonstrations here. Basically what we have, this is a GFX bench running. So what that means is it's OpenGL based. It's very intense, making sure we're kind of pushing as many pixels as possible. That just happens to be one of the virtual displays. I'm going to go to the back here, back seat, fly back. You start another one. This is Vulkan based. Okay, so it's very showy. We've got video running in the front as well. The cool thing is, I also have the ability, because we're running Unity as the graphics backend, you can kind of fly around the cabin with all these virtual displays. And they're going to zoom in and out. But the neat thing is, I can even interact with them, kind of as they're in motion. So we redefine the touch points, allowing us to manipulate this wherever it happens to be.
Yeah, that was pretty cool. That as it's moving, it's still keeping context with what you're tapping.
We're very showy. We're at CES. We wanted to showcase that it's possible for us to integrate and shift things around even when it's kind of on the move. Because we wanted to make sure that we were clear that this wasn't just a video, that we were just kind of moving and manipulating around.
Right.
And when it actually comes into play, you can see the cameras as well are all live as well. So I can move in and out there. We've got Netflix in the back there too. Video that happens to be going on the instrument cluster. So it's really whatever you would like. We kind of have the ability to run all that isolated at the same time. Other things I can touch on. We got. I'm going to do the driver monitoring system. So this is with using Seeing machines. So I'm just going to switch this view. So this is an Android application we have over here. I'm going to switch the instrument cluster to Seeing machines. So I'm going to switch my position to over on this side, just so I'm kind of in frame. So you can see it's QNX because it's wrapped in blue there. So this is the Seeing machines interface. I'm going to push that to the front, just make it a little bit bigger so it's easier to see. You can understand why we've kind of made it so we can manipulate this content. So I can simulate that I'm smoking, and you can obviously see the gaze detection there. I can just kind of keep my chin still and move all around, and I'm able to simulate having a phone detected there. So we're using the API to communicate from Seeing machines to Android. So one other thing, we can go sleeping. So I can just close my eyes and it's going to do a micro sleep up there.
Yeah.
And that kind of demonstrates the what happens when you have the driver monitoring system from Seeing machines integrated.
What about when my teenager starts to text? Can I get an alert on that?
I suppose you could if it was in frame. There's no reason why I wouldn't allow such a thing. Okay. One other thing I can touch on is acoustics.
Yeah.
So what we have is this is a sound bar, 16 channels. It's challenging to kind of differentiate which speaker you're at. So we put the lights beside these to indicate which speaker we're kind of driving. This is an A to B connection, so it's very lightweight as far as the physical wiring in a car, as well as the lightweight nature of the amplifier that's being used. So it's quite cost effective to use one of these rather dumb amps, is what the terminology. So what we're going to do is I'm going to just switch over. I'm going to play some music here. And it's going to play to the kind of the rear and front of the car. I'm going to switch cluster control. So I'm going to simulate different actions in the car. So there's my left turn indicator. That's going to indicate that I've got that speaker
that's
power.
pretty cool. Yeah.
So same deal over the right, obviously.
Yeah.
But I just happen to reach the end of the song, so it's not. There you go. So collision warning. It's going to use ducking. So the music in Android that we control, we stopped or paused the music in Android, and then it resumes once the critical alert has passed. We can also indicate which doors are open, these sorts of things. But more importantly, we have a bit of a simulation. So this is where you get into the engine sound enhancement. But all of this is done without a DSP. So what that means is you were able to shift this from one SoC to another, because we touched on being able to use this in the cloud, using it with the Samsung hardware, the MediaTek. As long as it supports Bird.io, you have the ability to shift these things back and forth between different hardware.
That's great. That's amazing for developers. I'm sure that's music to their ears, literally. To be able to, basically develop once and then be able to maximize the footprint that they can go after.
Absolutely. You never want to be beholden to one hardware vendor. You want to be able to shift as required. And spinning up people in the cloud is incredibly beneficial to get as many people working on that as possible.
Yeah, especially since sometimes you need to be able to develop as the hardware is still being developed potentially, and then you can hit the ground running as soon as it becomes available.
Yeah, because with hardware, even though we are a software company, we found with hardware, you have a version 2? Oh, you don't want the version 2, you want the version 2.1.
Right.
So to spin up all your teams with the proper hardware is a challenge. So we want to make sure we can facilitate that. The reason why we integrate all of this together, the last 10% of a project takes about 90% of the time. We want to make sure that we reduce that time of integration, or some people refer to as integration challenges. We want this to go as quickly as possible. Reducing the time to market for our customers is critical.
Perfect. Thanks, Mike. Appreciate it.
Thank you very much.